Friends, now we are going to I'm going to introduce to you another progression called geometric progression. In arithmetic progression also we started with a fixed number a and we kept on adding a number called d, and that is how we generated a sequence, and that sequence was called arithmetic progression. In this case also we'll start with some number a and we'll keep on multiplying it by some another number. Say for example, suppose I start with 2, okay, and I multiply it by 3. So what will I get? 6. I multiply it again by 3. So it will be what? 18. I again multiply by 3 and I just keep on multiplying by 3 and I will get the next term. So this kind of sequence is called geometric progression. So for example, if I start with 1 multiplied by 3, then multiplied by 3 will be what? 9. Then multiplied by 3 will be what? 12, and so on. So this kind of sequence which is generated by starting with any number you like and multiplying it by same number again and again, that will be called a geometric progression. So this is the first term, right? T1. This is what? T2. This is what? T3. This is T4. Now what is the defining property of this? T2 divided by T1 is always 3. Then T3 divided by T2 is also 3. So T4 divided by T3 is always 3, and this goes on. So in general, the next term, that is Tn divided by Tn minus 1, the previous term, is always equal to same number what? 3. Correct? So in the arithmetic progression, difference between the two numbers was constant. Here, the division of the two consecutive terms is always constant. So that gives me the definition of geometric progression. So what is the geometric progression? It's, of course, it is in short it is called GP. Remember. So how do you define a geometric progression? A sequence of numbers, sequence of real numbers in which ratio, that is division, of two consecutive terms is constant. Constant is called GP, or geometric progression in short. Now that constant ratio that we spoke about is called common ratio, right? So, right, the constant is called common ratio, and it is denoted by R, a simple letter R. So that means if I want to construct any geometric progression, I start with some number a, right? I'll multiply it by R, so I'll get AR. I'll multiply it again by R, so it is AR square. Again multiply by R, it is AR cube, and so on. Now if you look at it, this is first term, this is second term. What is the power of R here? 1. This is a third term. What is the power of R here? 2. So it is 1 less than this term. This is T4, power of R is 3. So in general, if I want to write Tn, it will be A R raised to n minus 1, right? That is how a geometric progression can be constructed, correct? So let us see, for example, suppose I start with a number called 1. I multiply by, say, let us say 1/3. Then again multiply by 1/3, so it is 1 upon 9. Again multiplied by 1/3, that is 1 upon 27, and so on, correct? And I want to find out nth term. I know the formula for nth term is given by A R raised to n minus 1. Now here A, which is 1, multiplied by R, which is 1/3, raised to what? N minus 1. So it is 1 upon 3 raised to n minus 1. That is the nth term of this progression, correct? So that is how you can find out nth term of this progression. So now this is Tn, right? So now once you know the formula for nth term, suppose I start with 3 and then my multiplied by 2, 6, again multiplied by 2, it is 12, again multiplied by 2, it is 24, and so on. Here I have chosen A as 3 and R as 2. So therefore Tn will be given by 3 multiplied by 2 raised to n minus 1. I think that should be very simple for you to understand. This is how nth term of a GP can be found out. As I did in the last time also, immediately I want to create a series out of it, So what is a series? I am adding the nth term of a GP. So what is the formula for nth term, a sum of n terms of a GP? What is the formula for sum of n terms of a GP? Now that's very interesting. I want to find out Sn. What is Sn? Sn is first term A, second term is AR, third term is AR square, and so on and so forth till I reach what? AR raised to what? N minus 1. This sum I want to find out. Now there is a very clever trick in finding out. What I am going to do is, I am going to multiply both sides by R. Multiplying both sides by the common ratio R. So what will happen? Here also it gets multiplied, so it becomes R times Sn. Correct? Now this A is being multiplied by R, so it becomes AR. I'll write it below this. So A multiplied by R, AR is here. Now AR multiplied by R is AR square. It will be here. AR square. This AR square is multiplied by R, so this becomes AR cube, like that. In general, now I'll keep on doing that. So last AR raised to n minus 1, this last AR raised to n minus 1 is being multiplied by R. So what will happen then? AR raised to n minus 1 multiplied by R means, according to laws of indices, A into R raised to n minus 1 plus 1. So that gets cancelled. So what you get is AR raised to n. Right? So then this is AR raised to n. Now what am I going to do now? I'll write it clearly here. So this is this term was A. This term was A R raised to n minus 1, which I multiplied by R, and I got A R raised to n, right? Now what am I going to do? I am going to subtract these two equations. Okay? What will happen is something very magical. So it is Sn minus R times Sn. What happens here? This A remains here, right? But this AR gets cancelled, AR square gets cancelled, AR cube will get cancelled. This AR raised to n minus 1 get cancelled with the previous term. Only thing, this term will be left. So there are only two terms left. AR raised to n. Fantastic. That means you take out Sn common, it is 1 minus R. You take out A common, it is 1 minus R raised to n, right? Therefore, Sn is given by A multiplied by 1 minus R raised to n divided by 1 minus R. You all know from the normal arithmetic that if I change the order in the numerator and also in the denominator, the answer doesn't change. So it is A multiplied by R raised to n minus 1 upon R minus 1. Both formulas are equivalent, right? So this is how you can get sum of n terms of an arithmetic geometric progression, right? So this is the basics of arithmetic and geometric progression, and I may do certain problems in the another lecture, but this is how geometric progressions can be done. Okay, fine. Thank you.